So I was expecting that most of you would, your favorite programming language would be C# and your least favorite programming language would be JavaScript. So what we're here to talk about today is the future of web programming and the benefits of migrating from JavaScript to TypeScript. So first of all, let's talk about the history of JavaScript. Why is JavaScript our least favorite but very important language? Well, Douglas Crockford is the inventor of JSON, JavaScript object notation, kind of an alternative to XML. He wrote the book on JavaScript, and even he says JavaScript is an astonishing language in the very worst sense. So those of us who are experienced with JavaScript and have seen some of its quirkiness, like the fact that for each loops don't work right and variable scoping is very strange, can agree that JavaScript is full of nasty, nasty surprises. The question is, how did JavaScript get to be so awful that even its biggest proponent, Douglas Crockford, would say something like that about it? Well, JavaScript was designed originally in May 1995 by a man named Brendan Eich. And he spent 10 whole days designing the most important programming language that pretty much in the world at this point. Maybe arguably C might be more important, but JavaScript is certainly a contender. And it took him only 10 days to design it. How many great things in the world are only done in 10 days? Not very many. That's an awfully short amount of time. So he designed it in May, and it went to production by September. So 4 months to go from design to production in Netscape Navigator. How many of you remember this logo back from the 90s? I remember that. So 4 months from design to shipping. I know most of us wouldn't expect high quality results from that. So Netscape was the first browser to include JavaScript. Then about a year later, Microsoft reverse engineered Netscape's implementation of JavaScript and included it in their Internet Explorer browser along with VBScript. Netscape saw this, and rather than making JavaScript a proprietary language, they began standardizing it. How many of you don't know what ECMA script is? Raise your hand if you don't know what ECMA script is. All right, very good. We've got lots of hands. So ECMA script is the standardized specification of JavaScript that real browsers can model their implementations of JavaScript against. So it's just a specification, not an actual implementation. There are sites out there that can take browsers and measure the browser's implementation automatically against the ECMA script specification for what JavaScript should be.
Something like that.
So those are nice things. So to make JavaScript non-proprietary, the ECMA, European Computer Manufacturers Association, something like that, it doesn't stand for that anymore, but that's what it originally stood for, did the spec in 1996. So, this was an incredibly rapid timeline for the development of JavaScript. So, immediately people saw how awful JavaScript was, and they started working on alternatives. How can we fix the problems that JavaScript brings to the table? So the first one, I have the major ones written down here. The first one was VBScript. Now that was Microsoft. They wanted to make VBScript the standard for all scripting languages, and so they included VBScript and JavaScript together in Internet Explorer's original implementations. And to my knowledge, VBScript is still there. The problem was with that, the reason it didn't take off is because why would you code in VBScript and only work in Internet Explorer when you could code in JavaScript and have it work in any browser? So why would anybody do that? And they didn't. So VBScript is basically a dead technology. Microsoft decided to try again. They thought, well, maybe VBScript is, it's so limited that people don't find it worthwhile to learn a new language and embed it in the browser. So around that time they invented ActiveX, and ActiveX is a way to include real Windows executables inside of browsers. So you would have access to the full functionality of Windows from inside the browser. And I thought that sounded like a great idea, especially in a Windows-only environment. But that did not take off for security reasons, because giving browsers access to the full power of the operating system that they lived in is a security nightmare. So the ActiveX model was not very successful. So Adobe said, well, people are using Flash Player in the form of an ActiveX control in Windows and in the form of other browser plugins in like Linux and Mac. Other operating systems use different plugin technologies. Adobe said, well, we've got Flash Player installed on almost every operating system. Why don't we turn Flash Player into a platform for developing applications? Then everybody can go there. They can get the power of the Flash Player, which in turn has access to the operating system and can create an abstraction layer on top of it and give people great functionality. But Steve Jobs didn't like that, and he didn't include it in the iPhone, and I think that was the turning point for the Flash Player. So it didn't have the operating system dependency. It did have some of the security policies issues, not as bad as ActiveX. So it fixed the platform dependence. It improved the security situation. Still not good enough. Steve Jobs killed it. Microsoft decided that this in like 2006 decided, well, why don't we make a .NET version like the Flash Player so that it'll be a really great development program, and we'll manage it and we'll do a better job on the security than Adobe did. So they tried it, and that never went anywhere because they didn't bundle it in IE because they were caught on all of that antitrust stuff in the late 90s. So Silverlight failed. Google came in a few years ago and they said, all right, we've looked at all these mistakes. We will make the Dart programming language. This will be a new programming language that fixes all the mistakes of JavaScript. We'll avoid the browser compatibility issues of VBScript by making our programming language compile into JavaScript, so now it'll run on any platform. We won't have security vulnerabilities because it'll use the security sandbox that we already have. Unfortunately, Dart has also not taken off, and the reason for that is people did not want to learn a whole new language when JavaScript was good enough. They wanted to skip the abstraction layer. And there was a lot of tooling that had to be installed, so there was a bit of a hump for people to get over to get started with Dart. So I come here claiming that TypeScript has finally, after a decade and a half, more than of trying to escape from the nightmare that is JavaScript, TypeScript finally has a viable route. And that seems to actually be the case because it is taking off bit by bit. So for a lot of us, so TypeScript solved the problem of Dart by making a new programming language that is a superset of JavaScript. So every time you write a JavaScript, it is also a valid TypeScript. TypeScript being a superset. So it adds a few extensions to it that drastically improve the language without wrecking what already exists. So fully backwards compatible. And only small amounts of extra learning to get big results. So if you like C# You will love TypeScript because they were both invented by Anders Hejelsberg. He's the one who came up with the bright idea of avoiding the learning curve that was associated with Dart. So TypeScript 1.0 was released in October 2012, and it has been taking off ever since, bit by bit. Its purpose is not only to address the weaknesses that JavaScript has, but enable large enterprise organizations to support collaborative applications that happen on a larger scale than what JavaScript was originally intended to do. JavaScript was intended for little things. Anders Hejelsberg designed TypeScript for big, important things. So it compiles to JavaScript, no browser compatibility problems. Most important to you guys, it is included as a first-class language in Visual Studio 2017. If you create TypeScript files, they will automatically generate JS files, which can be referenced in your application seamlessly. Now, one concern that you guys might have about using TypeScript, a compiler that converts to JavaScript, is you might be wondering, well, how am I going to debug if I don't, when my JavaScript breaks, if it's showing me the JavaScript line, how do I know where the error happened in the source code that I wrote? Well, when Google was creating Dart to solve the same problem, they created something called a .map file. And what that does is it maps the generated JavaScript back to the original source code language so that all modern browsers, when they break with the .map file, it can show you the exact portion of the TypeScript that caused the error and make a reasonable error message associated with it, which works even better in TypeScript because the language is so close to JavaScript. You won't get much in the way of errors that look different between your source code and the source code that is executing in the browser. So what are now that we've addressed what TypeScript is and what general advantages it offers over JavaScript, let's talk about its the details. So first off is that TypeScript is an advantage over JavaScript because it allows code completion. Everybody loves IntelliSense in Visual Studio, and it's awful when you're doing JavaScript and you don't get that IntelliSense to know what functions make sense with what objects. Well, TypeScript does that. Secondly, it reduces the, good studies have shown that there is a significant reduction in the amount of bugs in your code when you use TypeScript. Third is that most browsers currently use ECMA script version 5. However, ECMA script version 6, otherwise known as ECMA script 2015, offers a lot of advantages, and you get those advantages right now without having to worry about browser implementations if you use TypeScript. Fourth, it offers features that aren't even in ECMAScript 6. Microsoft tries to keep TypeScript compatible with the direction of actual JavaScript. So it's being able to write code today that's intended to be run years from now, but you get all those benefits now. So let's talk about code completion. So here's an example. Somebody used jQuery. They used a jQuery selector, and look at that, they get all of the jQuery events, properties, attributes available in Visual Studio, along with data type information about what types these are supposed to be. And if you mess up on the data types, you'll get a compile time error instead of a really weird runtime error that involves a type mismatch. Secondly, a recent study showed that conservatively, TypeScript can prevent 15% of the bugs that end up in actual production code. Can you imagine reducing 15% of your bugs, what a difference that would make? saving our customers from finding those bugs. So let's talk about some of the benefits of ECMAScript 2015, otherwise known as ECMAScript 6. So one of the astonishing and kind of horrifying things about JavaScript is something called variable hoisting. So look at this little function here. So it has this for loop where it declares this variable niche inside this loop where it's going to loop 5 times. Well, it's not surprising that niche is available inside the for loop. What's astonishing is that the variable niche exists before it is declared outside of the loop and after the loop ends. That is a bizarre function of JavaScript. So in TypeScript, we should never use the word var anymore. We should only use the word let. Let declares a variable that works using the normal scoping rules that we're familiar with in C#. So if you declare the variable inside the for loop, it will only exist inside the for loop, not before it's declared, not after it leaves scope, only in the correct spot. So if you use TypeScript or your browsers are fairly modern, then just never use var again. Please don't. It's too weird.
What
Yes.
does let stand for?
What does let stand for? It's not an abbreviation. It says let.
Or be like. Oh.
It's just a keyword.
Oh, okay. I didn't know it's like an inbuilt keyword for TypeScript.
It is a built-in keyword.
Yeah.
Yes.
Okay.
So
You can do use strict, right, in regular JS code to enable let at the top of your
I
JS
think you
file.
don't even need to, that enforces it
Mhm.
depending on the browser. I don't think you
Mhm.
have to.
Okay.
But if you use TypeScript,
Yeah.
use strict is good.
Yeah.
All right, so the for each loop is really, really weird in JavaScript. And I don't think any of us have ever done for each loops in JavaScript, not in the code that I've seen in our organization. Please never use it. But ECMA script 2015 has an alternative syntax instead of for each. It has the for of. And I'm not going to talk about const, but consider const a very similar thing to let. It follows good scoping rules. And I'm not going to enforce this, but please use const instead of let if you can. All right, so a decent alternative to for each. Now this is something I don't know how much we're going to use, but it's really going to confuse you if you see it in ECMAScript 2016, so I'm letting you know so that you'll understand what's going on. Instead of putting you'll see that in previous versions of JavaScript, we always use quotation marks or single quotes as string literals. And then, of course, we use pluses to concatenate. So this is a very conventional set of lines of JavaScript code. When we move on to ECMAScript 2015, we get something called the template literal that works a lot like string format, where instead of using a single quote, you're using the accent mark or tick mark. And then when you put a $ followed by a curly brace, it automatically does a replacement for the variables in scope to put that into your string. So it avoids this long, nasty concatenation process. And interestingly, it allows multi-line strings. In this example, they had to do the /n to do the line break. In the template literal, you don't have to do that. You just put the tick mark to start, tick mark to end, and you're set. So another thing is that JavaScript, when it was born, it has this, it isn't a normal object-oriented programming language. It has something called prototype inheritance. That's a really hard thing to wrap your mind around if you were taught in school about normal object-oriented programming. So instead of this nastiness with this prototype blah blah blah, in ECMAScript 2016 you have a much more normal inheritance model where you can create a class, call it rectangle, and it extends or inherits from a shape class, and you can define a constructor in a fairly normal way. Now I don't know how much object-oriented programming we're going to end up doing, but is really nice for reusable code. And when you do it in TypeScript, to get all the type checking and verification is a really big advantage for reusability of the code that we write. All right, so this last item is even beyond what ECMAScript 2015 offers. That is async await. When you're writing JavaScript, probably most of you haven't run into this, but JavaScript, in order to give responsiveness to the customers, generally enforces an asynchronous model. If you try to do, for AJAX calls, if you try to do synchronous calls, it will lock up the browser while the network connection is going, and that will create a terrible user experience. So, async await was invented by Anders Hejelsberg for C#. However, he brought it over to JavaScript to provide you the illusion of a synchronous call, like we see down here. If we have a website that we need to get some AJAX data from, we say get string from web server async. We put the await keyword here, and it means that this line will not, the next line will not get executed until the data comes back or an error happens from the network call. This is much more convenient for programming, makes much more comprehensible, cleaner code than it does to write conventional asynchronous code without any of the downsides of responsiveness that synchronous code has. And so that concludes our presentation. Hopefully you'll all be eager to try out TypeScript. And since you love C# and you love Anders Hejelsberg, you're ready to go on to TypeScript. So that's it for my presentation. Any questions? Any thoughts by those who have tried TypeScript?
It's good stuff.
Have we started working on any pilot projects or testing on TypeScript at ITD? Or
Yes, Williams Group has already tried it out.
Okay.
James will brief you on the setup. Right, James?
What do you need to set up this thing?
There's a check. You don't have to do any setup, but to make TypeScript more reliable, there's a checkbox you check in Visual Studio. Otherwise, Visual Studio won't always compile it. It'll compile it under some circumstances and not others. So I can show you how to find that option in Visual Studio if it doesn't work out of the box, which it probably will.
I remember there was some file that we had to download too, right, James?
No, those are the TypeScript declaration file. So if anybody wants to work on it, I'll be more than happy to show you through how it works. So I hope you're all excited to do this, have less bugs and easier coding. All right.
Okay.
So thank you for that.
Thank you, James.